Question number 11. Question is given as thermally insulated rigid container contains an ideal gas at 27 degrees Celsius. It is fitted with a heating coil of resistance 50 ohm. A current is passed through the coil for 10 minutes. By connecting it to a DC source of 10 volt, the change in the internal energy of the gas is first option 0, second option 300 joule, third option 600 joule, and the fourth option 1200 joule. So here, what is the change in internal energy? Change in internal energy of gas, is equal to heat generate or electrical energy is equal to electrical energy dissipate across resistor. Energy dissipates across resistor. So this is your delta U, which is your V square by R into T, and V square by R. Voltage given here 10 square, resistance your 50 ohm, and time is given, it has been supplied for 10 minutes. So 10 into 60. So delta U, this will come into joule. This is your 100 into 600 by 50 joule. This is 1200 joule. This is the change in internal energy. So our correct option is your option number 4. Question number 12. The ratio of the adiabatic modulus of the isothermal bulk modulus of a perfect gas with degree of freedom is. So as we know, adiabatic equation is your this. PV to the power gamma is equal to your constant. So when we are finding the adiabatic modulus, just differentiate dP V to the power gamma plus gamma V to the power gamma minus dV into P, which is 0. So adiabatic modulus that is your minus dP by dV by V, which comes here gamma into P. Similarly, for isothermal process, PV is your constant. So isothermal modulus that is equal to your minus P. So ratio of that. So ratio that is your minus gamma P by minus gamma, which is minus P, which is equal to your gamma. Now value of gamma in terms of degree of freedom. So as we know, in case of degree of freedom, it is written as 1 plus 2 by F. F is the degree of freedom. So our correct option is your option number 3. Question number 13. A gas undergoes a change of state during which 100 joule of heat is supplied to it and it does 20 joule of work. The system is brought back to its original state through a process during which 20 joule of heat is released by the gas. The work done by the gas in the second process is. So first option you 60 joule, second option 40 joule, third option 80 joule, and the fourth option 20 joule. Now see the whole question here. As per the problem, a gas undergoes a change of state during which 100 joule of heat is supplied to it. It means let initially state number 1, state number 2. Now gas has been taken from this 1 to 2. Q1 is the heat supplied. Heat supply means given. It is undergoes change. 100 joule of heat is supplied to it. 100 joule. And it does 20 joule of work. The gas is doing work, that is your 20 joule. So work done by the gas. And work done by gas 20 joule. So change in internal energy we can get, that is your by using first law of thermodynamics. So Q1 is your work done plus delta U. So that delta U is equal to your 80 joule. Now in the another way, the system is brought back to the original state through a process during which now it has been back 2 to 1. In this process 20 joule of heat is released. Here Q2, that is release means minus 20. So they are asking the work done. See, as we know, internal energy of the system will remain your same. Change in internal energy will be your 0. Now, if this is your delta U to 1, 1 to 2, then same thing, delta U 2 to 1 will be your minus 80. So as per the first law of thermodynamics, Q2 is equal to your delta U 2 to 1 plus work done 2 to 1. Q2 is given your minus 20, delta U to your minus 80 plus work done 2 to 1. The work done 2 to 1 will be your 60 joule. So work done will be your 60 joule. So correct option your option number 1. Question number 14. Question is given as, in the PV diagram in figure ABC is a semicircle. The work done in the process ABC is first option 0, second option pi by 2 atmosphere liter, third option minus pi by 2 atmosphere liter, fourth option 4 atmosphere liter. See the how to do this one. PV diagram is given, pressure is given in the atmospheric pressure atm, while volume is given in liters. Now the process is like this. It is given here A, B and C, this much, and volume is here given 1 and 2, and while atmospheric pressure you have 1 in 3. This is your 1, this is your 2. This is 1 and this is given here your 3. The first thing is that here volume your decreases first, then here volume your increases. So the total work done will be here positive, because work done on this your positive. Why? Because first your volume you are decreasing, so this is the area, then the volume you are increasing, this is the area. Now total work done. Work done is equal to your area under this cycle. Area under this cycle your, according to the pi A into B, half this your by 2. So pi A is your semi-major axis here. This is your 3 minus 1, 2, 2 by 1. This is 2 by 2. This is your 1. And here your 1 and 2, semi-major axis here, it will be your 2. This is also your 1 by 2. So this will be your pi by 2 atmospheric into liter. So this is the correct option. So option number 2 is the correct answer. Question number 15. The variation of temperature along lead rod is shown in figure. Flow rate of heat per unit area is 2 kJ per meter square second. Then the thermal conductivity of rod is. So there are 4 options are given. Option number 1, 0.04 watt per meter Kelvin. Second option, 20 watt per meter Kelvin. Third option, 0.02 watt per meter Kelvin. And the fourth option, 40 watt per meter Kelvin. So as per the graph, in the graph it is given temperature. This is your temperature, and here it is given length. And the change in temperature is given like this. This is your 373 Kelvin, and this is given here 173 Kelvin in a length 0 to 4 meter, and this is your 173 Kelvin. From the graph we can get dt by dx, which is equal to your the slope of this minus this is your 200, this is your 4 to minus 50. As according to law of thermal conductivity, Q is equal to your minus Ka dt by dx. This is the thermal conductivity. Now, as per the given information, it is given the flow rate of heat per unit area. It means Q by A. Q by A is your minus K dt by dx. That Q by A value is given here 2 kilojoule. The 2 kilojoule and area, kilojoule means this joule per second. This is your minus K dt by dx is your 50. So K is 2 into 10 power 3 by 50. So this is 200 by 5, which is your 4 joule per meter per second Kelvin. So our correct option is your option number 4. Question number 16. 2 moles of an ideal monoatomic gas at temperature T0 is mixed with 4 moles of another ideal monoatomic gas at temperature 2 T0. Then the temperature of the mixture is. First option 5 by 3 T0, second option 3 by 2 T0, third option 4 by 3 T0, fourth option 5 by 4 T0. Now see how to do this one. Since the whole system is isolated from the surrounding, the total energy of the system will remain constant. So one of the gas will lose heat. The heat lost is equal to, we can say, heat gain. Let final temperature your T. Final temperature is T. Since the higher temperature gas will lose heat and lower temperature gas will gain heat. So heat lost, and both of the gases are your monoatomic gases. The heat loss relation N1 CV1 delta T is equal to your delta T1, we can say, N2 CV2 delta T2. Heat loss by higher temperature body. Higher temperature body have 4 moles gas and temperature your 2 T0 monoatomic. 4 2T naught minus T. Since Cv they both are monatomic and lower temperature body have number of moles here 2 and this temperature here T minus T naught and Cv1 is equal to Cv2. Both are monoatomic. So Cv1 is equal to Cv2. Now we can simplify. 2 and 2 cancel here. 4 T naught minus 2T is equal to T minus T naught. So T is equal to 5 T naught by 3. Final temperature is your 5 T naught by 3. The correct option your option number 1. In question number 17, heat is supplied to a diatomic gas at constant pressure. The ratio of delta Q by delta U and delta W is. First option 5:3:2. Second option 5:2:3. Third option 7:5:2. And the fourth option 7:2:5. This is your diatomic gas at constant pressure. It is given information. Diatomic gas at constant pressure. So they are asking delta Q, ratio delta U, ratio delta W. As from first law of thermodynamics, delta Q is equal to delta U plus W. So W is your delta Q minus delta U. So this further written as delta Q ratio delta U ratio delta Q minus delta U. And at constant pressure, at constant pressure, delta Q always NCP delta T, and internal energy delta U always written as NCV delta T. See here, that can be written as NCP delta T ratio NCV delta T ratio N Cp minus Cv delta T. So Cp ratio Cv ratio Cp minus Cv. For diatomic gas, Cp is equal to your 7/2R. 7/2R. Cp is your 5/2R Cv, and Cp minus Cv is always 2R. Cp minus Cv. 7R minus 5R always R. So this further written as 7:5:2. Hence answer is your 3 is the correct option. Question number 18. In an adiabatic expansion, the product of pressure and volume. So first option decreases, second option increases, third option remains constant, and the fourth option first increases and then decreases. They are asking the product of pressure and volume. If we are looking the adiabatic graph, P versus V graph for adiabatic process. So this is the area, and that graph indicate expansion because volume is increasing. So what we are observing here, you see, as we are going, if we are looking the slope here, if we are looking the slope here, so what it appears, the slope is gradually decreases. Slope is decreases, so area under the PV curve is also gradually decreases, and that area under PV curve is nothing, it is the product of pressure and volume. So we can say in adiabatic expansion the product of pressure and volume is always decreases. So option number 1 is the correct option. Question number 19. During an adiabatic process, the pressure of a gas is found to be proportional to the cube of its absolute temperature. The ratio for Cp by Cv is your gamma. The gas is, first is your 2, second is 3 by 2, third is 5 by 3, the fourth is 4 by 3. As per the given condition, the process is your adiabatic, and here the pressure of gas is proportional to cube of its absolute temperature. So P is proportional to T cube. We can say P T to the power minus 3 is equal to your constant. The first thing for adiabatic. For adiabatic process, PV to the power gamma is constant. By using ideal gas equation, volume can be written as nRT by P. Gamma is your constant. So P 1 minus gamma, T to the power gamma is your constant. Then P T to the power gamma by 1 minus gamma is your constant. So for adiabatic process, this is the relation between pressure and temperature. If we are comparing this with this, then we can say on comparing, then we can say minus 3 is equal to gamma by 1 minus gamma. So this will give us the value minus 3 plus 3 gamma is equal to gamma, or 2 gamma is equal to 3. So gamma is equal to your 3 by 2. So our correct option is the option number 2 is the correct option. Question number 20. Figure shows a cyclic process ABCA for 1 mole of an ideal gas. If AB is isothermal process, then which of the following is the PT diagram for the cyclic processes? There are 4 options are given, 1, 2, 3 and 4. Now we will find which one is the correct option. The graph is given here. So first see our question here. In this question here, PV diagram is given. And in this PV diagram, so process is like this. And in this process, A to B, AB is isothermal process. So A, B and C. And now they are asking to convert this into PT diagram. Here volume is your V and this is your 2V. Here pressure your P, this is 2P. So we have to make our PT diagram where P is in the y-axis and T is in the x-axis. First see, if I am looking A to B as per it is given isothermal, this is your isothermal. Isothermal process means temperature of A to B your constant. The constant temperature line will be your like this. This is your constant temperature A to B. From A to B, as we are looking, pressure your decreases. Pressure your decreasing from A to B. So this point must be your A and this is your B, like this. Next, B to C, if I am looking here, so what has been observed, the pressure is your constant. Pressure constant, if volume is decreases, so temperature will also decrease. So this is your B to C. Pressure constant, volume decreasing, temperature will also decrease. Now C to A. C to A, volume constant. If volume is constant and pressure is increasing, so temperature will also increase. So temperature increases like this straight line. So this is your C. So this is your PT graph. So as per the given graph, so fourth option is our matches with the given options. So answer is your fourth option is the correct option.